Biofilters. Biofiltration is mainly used for elimination of odors of gases and low concentration of volatile organic compounds. The process of biodegradation is given by organic pollutant plus O2 gives CO2 plus H2O plus heat plus biomass. Components of a biofiltration unit. The filter consists of a closed chamber containing contaminants, degrading microbes, and absorbed water suspended in a filter medium. 1. Filter media. The moist filtration medium provides physical and chemical conditions suitable for the transfer of contaminants from the air to the liquid phase and the biodegradation of the contaminants in the biofilm layer. The purpose of the biofilter media is to provide a large surface area for the absorption and adsorption of contaminants which provide a low pressure drop for the gas passing through the media and have a long working life. Typical biofilter media material includes compost based material like earth, plastic, or wood product based materials. The media also serve as a nutrient source for the microbial population. Sometimes of media lack proper nutrients and will require the manual addition nutrient. Example, nitrogen and phosphorus components. In order to sustain microbial life, most biofilters will operate for 5 to 7 years before it is necessary to renew the filter media. 2. Support bed. Perforated support rocks are used to permit the air from the plenum to move into the bed media and to contact microbes that live in the bed. Perforations also permit excess condensed moisture to drain out of the bed to plenum. 3. Collecting fans. Collecting fans are used to collect contaminated air. As the emission flow through the bed, the pollutants are absorbed by moisture on the bed media. Microbes reduce pollutant by consuming and metabolizing pollutants. Types of biofilters. Biofilters are classified on the basis of a layout. In layout, it is classified into two types. They are open bed and closed bed. In open bed, uncovered and exposed to all weather conditions. In closed bed, enclosed with a small exhaust for venting of cleaned air. B. Based on shape, it is classified into two types: 1. Horizontal and vertical. In horizontal, it is easy to maintain with larger footprints. It is relatively inexpensive. In vertical, designed to reduce the footprint required, use less surface area compared to horizontal, not easy to maintain. C. Support media. Based on support media, the biofilter classified into two types: 1. Compost biofilter. 2. Synthetic biofilter. In compost biofilter, soil, peat, and compost materials is used. In synthetic biofilter, ceramic, plastic, and wood products are used. Factors consider while selecting filter material: 1. Ability to retain moisture to sustain biofilm layers. 2. Large surface area both for contaminant absorption and microbial growth. 3. Ability to retain nutrients and supply them to the microbes. 4. Low resistance to airflow. 5. Physical characteristics such as physical stability and easy handling. Filtration process. The mechanism of the biofiltration process includes a combination of adsorption, absorption, and microbial filtration. Movements of the contaminants from the air to water phase occurs. Microorganisms contained in the biofilm layer continuously metabolize the contaminants as they are absorbed and converting them ultimately to water, carbon dioxide, and salts. The contaminants in the gases are either absorbed onto the solid particles of the media or absorbed into the layer that exists on the media. Contaminants decreases from inlet to outlet as they partitioned between various phases. Waste partition out between soil and gases so that the VOC, that means volatile organic compounds, remains in soil longer than in air. Then diffusion occurs through the water layer to the microorganism in the similar layer on the surface. Through biotransformation of the food source, end products are formed, including carbon dioxide, water, nitrogen, mineral salts, and energy particles are produced. Biotransformation acts along with adsorption, absorption, and diffusion to remove contaminants from the gaseous stream. The media of the filter functions both to supply inorganic nutrients and supplements to the gas stream being treated for organic nutrients. The sorbed gases are oxidized by microorganisms to CO2. Design requirements. Space requirement. A small biofiltration unit can be designed to handle approximately 30 cubic feet per minute per 25 square feet area. Chemical constitutions and concentrations. Biofilters performed best when treating hydrophilic components in low concentrations. Then retention or residence time. Residence time is the time duration for which the microbes are contact with the contaminated airstream. Residence time is equal to void volume divided by volumetric flow rate. Humidity. The humidity of gas stream is important for maintaining the moisture content to the biofilter media. The gas entering the biofilter should be humidified to greater than 95% relative humidity. Then pH control. pH of the vessel is around neutral or a pH of 7. Buffering materials may be added to the organic media to maintain the pH. Then pressure drop. Pressure drop across the biofilter vessels should be minimized since an increase in pressure drop requires pressure drop is directly related to the moisture content in the media and the media pore size. Increased moisture and decreased pore size results in increased pressure drop. For a typical biofilter, pressure drops ranges from 1 to 10 HPa. Then maintenance. The operation and maintenance of the biofiltration system would require weekly site visits during initiation of operation for emission. However, after accumulation and all system problems are resolved, the frequency of site visits could be reduced to monthly. Advantages of biofiltration. The main advantages of using biofiltration over other methods is it is more convention to control low concentration VOCs and lower capital cost, lower operation cost, low chemical usage, and no combustion source. It can be designed to physically fit into any industrial setting, any shape, size, or as open field with the piping and delivery system in underground. In addition, biofilters can be designed with stacked beds to minimize space requirements, and multiple units can be run in parallel. Different media, microbes, and operation conditions can be used to tailor a biofilter system for many emission plants. Disadvantages of biofiltration: biofiltration cannot successfully treat some organic components which have low adsorption or degradation rates. This is especially true for chlorinated volatile organic compounds. Contaminant sources with high chemical emission would require large biofilter units or open area to install biofiltration system. Accumulation periods for the microbial population may take weeks. Source with emission that fluctuated severely or produce large spikes can be detrimental to the biofilter microbial population and its overall performance. Thank you, learners.